that makes it different from a z-test or a t-test from a population mean. So proportion, when I'm talking about proportion, I'm talking about a percentage. Like a percentage like this. If I made a statement that 25% of employees said their job causes stress, well, this is a proportion. This is what we're going to test, this claim. Our steps remain the same. We're still going to use the 4 basic steps that we've been using in hypothesis testing, only some of our conditions, the way we do our calculations, and some of our context is going to be tweaked a little bit. So let's highlight those differences. First off, instead of testing the mean, we're going to be testing proportion. We're looking at P rather than mu. Our second difference comes to us in step 2, our conditions. Normality is going to be shown by having a large sample size, but we can't use the central limit theorem like we do in mean testing. Instead, we're going to say the sample size times my hypothesized proportion is greater or equal to 10, and the sample size times the complement of the hypothesized proportion is also greater or equal to 10. Finally, in our calculations step, we're looking at a completely different set of computations. Well, maybe not completely, but certainly a little bit different. We're back to table A, talking about a z-score with proportion. It's going to equal my sample proportion minus my hypothesized proportion divided by the standard deviation of the estimate. That's the standard deviation of my hypothesized value, square root p sub naught times 1 minus p sub naught all over my sample size. Contrast that with means, we see that they're similar, but again, we're inputting different values. So these are the major 3 differences when it comes to population proportion and hypothesis testing here as opposed to the mean.